Asteroid mining. And it kind of fallen into disrepute for a while there. And actually, it's making kind of a renaissance in terms of investment and interest. So we'll talk about that today. Yes, it is actually coming back. To talk about that, first you've got to talk about the different kinds. There's really two major categories of mining in space in general, not just asteroids. One is to return things to Earth and use on Earth, which means you're competing against terrestrial mining. And that might be things like platinum or other things like that. The second alternative, is for using the products in space. Why would you do that? Well, the big thing is it costs a lot of money to launch stuff from Earth up into space, like water or propellant of any type. Anything that you can get in space will probably be a lot cheaper, and because you don't have to pay the price of getting off Earth, so it avoids that cost. And as a kind of a side note, this particular use is probably more likely to really result in more rapid expansion into space, because what you're really doing is you're saying you're reducing the need to depend on Earth. And the more that you can do that, the faster you can expand. So the history, though, what happened? There was a big burst of enthusiasm in the 2010s, early, almost through the end of the decade, with Silicon Valley backing. I mean, people like Larry Page and Eric, what's his name, from Google, and a lot of people backed it. It really got excitement going. The problem was it was just really a little bit ahead of its time. There were two companies that soaked up a lot of money on this. Planetary Resources and Deep Space Industries. Those were the two. Now, usually you think about metals when people talk about mining. Your usual image of mining is there's a bunch of stone or a cave or something, and you're digging into this with heavy-duty machinery. And actually, that's not what they're doing at all in this particular case. They were planning on extracting water. I mean, water is really a valuable commodity because, one, you can drink it, but two, you can turn it into rocket fuel. Separate it with electrolysis, separate it into hydrogen and oxygen. You have components for rocket fuel. And actually, in the DSI case, they had a different approach. They were actually making engines where they simply used water as propellant, meaning they basically just heated it up really hot, shot it out the back. That's reaction mass. You go that fuel goes that way, rocket ship goes that way, and they were doing that. And the reason for that is you have plenty of solar energy to heat it up, and so that was their approach. But they failed. Both of these companies were complete failures. They got acquired. By 2018 or 2019, they were gone. One of them got bought by a blockchain company. Nobody ever figured out why, but they were just basically acquiring some of probably the computers and stuff. It was really odd. The real problem, though, fundamentally is the business model. And the business model, it really goes beyond, say, a capitalist approach. I mean, it's true, even if you have a command economy, where do you invest your money? And it just turns out it was too high a risk and too long a payback time, really. You couldn't do it. There was no customer base. Nobody needed the water yet. And that's kind of you have one of those chicken and egg kind of situations. If it were available, people would use it. But how do you kick that off? So the investors really couldn't wait. It was going to take probably more than 10 years. The other thing is there was a lot of competition for funding from other new space companies. People building a lot of low Earth orbit satellite constellations for internet and that sort of thing. It seemed like an easier payoff over a short period of time. So that's where the money went. More fundamentally, though, there's simply not enough prospecting going on. People don't really know, well, what's in all those asteroids. We do have an idea. They've categorized asteroids by, some of them have a lot of carbon compounds, some have a lot of metals, and so they have some of that, but it's from a distance. They're basing it based on reflected light and what's in it. You don't really ultimately know what's under the ground there, so you don't know it completely. So there's a high cost there of finding those asteroids. And there's a lot of uncertainty in how do you get it back to Earth in any case. They fundamentally just ran out of time. They didn't have the funding to last to find out if their technology would even work. And the other thing that tended to get overlooked is you really need infrastructure already in space. If you're going to bring back stuff for sale in space in particular, you need save fuel. Well, you need a place to put it. You need a gas station. You need a depot of some sort. You need a place to meet, even if you're just going to send something up and pick up some fuel, some water or whatever, and move on. You need a place to do that. The other thing, though, is that these companies, they actually had technology that had alternate uses, and they could have sold it. And they tried kind of half-heartedly, and they didn't really do it. They should have, because that helped pay the bills. And actually, one of the newer companies really highlighted that as why they're going to succeed, but the others didn't. So, for instance, Planetary Resources, they had special sensors for really detecting what was available on the asteroids, and because they needed it. But actually, other people cared about that too. They had space telescopes that could help do that as well. In the case of DSI, they were developing this water propulsion system, which actually had some promise, and they could have probably sold that, but they didn't. So the changing environment here is because of a couple of things going on. First of all, there's a lot more activity in space now than there was even 10 years ago. and all these new satellite constellations going up, there's a lot more demands for services in orbit, which means a lot more satellites. A lot more satellites are going to die and have to be removed and need a mechanism for that. Sometimes they need to be serviced in the case of the really expensive ones that are high up. There's a lot of things going on, and you need propellants. If you're going to go around and collect that stuff, you need propellant to do it. So there's a lot more market shaping up finally for doing stuff in space. Maybe you can start delivering fuel, in particular, in space. Now, everybody does expect launch costs to drop. It's been dropping. We're at a factor of like maybe 1/10 of what it used to cost in the space shuttle days, mainly because of the Falcon 9. And the next big step in particular is going to be Starship, which is probably another factor of 10, maybe more. So that lowers the cost of getting all this equipment up, to do the mining. That's great. Of course, on the other hand, that actually hurts them because that means they're still competing against Earth-based sources. So if you're trying to put a bunch of water up there, it's a lot less expensive to do it with the new rockets. So there's a little bit of a trade-off there. But fundamentally, the business is growing mainly because of being enabled by having lower launch costs. Space law has been a big concern, maybe less so now than in the past. It goes back to a couple of treaties. The Outer Space Treaty, in particular, is a big one. It had ambiguities. It made it clear that no country and probably no company could actually own a place. There's just no ownership of land or even places, like say, in orbital position or something. But on the other hand, you also said that, well, if somebody's there, you can't really interfere with what they're doing. So you have kind of a squatter's rights situation. Little murky, but fundamentally, that probably didn't stop things too much. But it was ambiguous, so that made people nervous. The other thing is it wasn't clear on who would really benefit. You put a lot of investment in, again, whether you're doing it as a company or government, you'd probably like to know that you're going to get some payback from that. Well, there was some vague wording in the Outer Space Treaty about, well, all this should go for the benefit of all humanity. And what does that mean? Setting up an organization to distribute, should Nicaragua get a share of, what people put in, or got back out from mining or something? It wasn't very clear. Realistically, that's just not going to happen. The US actually has definitely gone the other way, but the reality is countries like China or Russia, they're not going to share the wealth with anybody either. So that's really not an issue. The US still has actually formalized it. They passed this thing called the Space Act in 2015, and it gives property rights for material that you extract. Nothing about owning the ground, but if you extract some platinum or some water, you're free to resell that any way you want. And so the U.S. said, well, that applies to U.S. companies. They can't say what happens to others. But then we came up with the Artemis Accords, which essentially uses that same philosophy. It says, we believe in the Outer Space Treaty, but it was kind of ambiguous. We're going to state clearly, if you extract it, you're free to use it as you would see fit. And that's actually what you need if you want anybody to invest, to have the confidence that it's worth spending all the money to develop mining if they can't get the benefit from it. So there's still challenges. The biggest one is still economics, the business model. It takes a lot of funding because there's always infrastructure you got to build up, and it takes a long time to get it back. And how many people want to wait 10 or 15 years in a high-risk environment like that? What's the odds of a company lasting 10 or 15 years in this business? And of course, related to that is market size. It was zero. Everybody believes there is a market for, say, delivering water or fuel up in space, but it's not really proven yet. So that's still an issue. Now it kind of goes the other way. People have written a lot of articles saying that there's a lot of money to be made out there. For instance, the one particular asteroid everybody talks about is Psyche. That one is thought to be pretty much made up of metal. For a long time, they thought that maybe it was actually a former core of a planet, which got split apart. Maybe it is, maybe it isn't, but it's probably all heavy metal. So if they actually valued that, they said, okay, that's $10 quintillion worth of material. Obviously, that's sort of an irrelevant number because if it actually started coming back in any quantity, that would depress the prices. So, that was kind of a concern, but that's sure a concern we'd like to have. Let's worry about what if we had too much platinum? Wouldn't that be a shame? But a related problem hasn't gone away, and that's you have to find these asteroids. There are a couple of really big ones like Psyche where it's probably pretty obvious that there's resources there. But if you're looking for water, not quite as clear. If you're looking for carbon compounds, maybe not. You need more work to find where these are. And then there's the technology. How do you extract it in a reasonably economical way? How do you transport it and store it and all that stuff? And there's still some risk in law, but again, that's not the biggest concern now. So we've learned more about asteroids in recent history. There have been a lot of missions, including ones returning samples.
we have a question online
Yeah.
about, do you have anything about the safety of asteroid mining?
No, it's clearly unsafe. But the good thing is, but the good thing is there aren't going to be any people involved in this, so it doesn't really matter. I mean, yeah, it's an investment risk. You know, your equipment may get destroyed one way or another. But these things take way too long. You know, the missions are going to involve years. You know, do things economically. You're going to go out in orbit for a couple of years. Things going to sit there, and with a small amount of energy coming on, you know, some solar collectors, you know, do some mining, or you know, after you're there for a couple of months or maybe another year, you'll eventually bring it back, and that takes another year. I mean, you're not going to have people involved in this. This is purely an automated kind of thing. So probably not safe, but it doesn't really matter. It's investment risk. Anyway, the Japanese were actually first. They had two different missions to return samples. The first one got only very small quantities. The second one returned quite a bit more in 2020, and they're still analyzing that. NASA had a mission called OSIRIS-REx, where they went into this asteroid Bennu. These asteroids are showing up here. They've got samples, and again, all the analysis is still going on, but at least you know, it's in progress. You know, NASA did the DART mission, which was for a planetary defense test. You know, you smash into an asteroid, can you change its course? But also in the process, when you smash into an asteroid and it kind of turns to dust, this kind of gives you an idea of the way it's structured. It's not really a big solid rock at all. And that's one thing, well, you'll see in the next slide, that basically most of these asteroids are officially technically called piles of rubble. That's or maybe rubble pile, I think is actually the technical term for it. But they're just kind of held together loosely by gravity, and probably pretty easily broken up. Now, Lucy probe, that's been launched, but that's going to go look at the asteroids near Jupiter. There's a couple of points where they tend to collect. They're going to visit them. They haven't gotten there yet. That takes several more years. And then the Psyche mission that NASA is launching this year will be going to that metallic asteroid. Finally, no one has ever visited. I mean, no spacecraft has ever visited a metallic asteroid yet. So that picture of Psyche, that is completely a figment of imagination of an artist. There's no particular basis for that. Just you had to draw something. NASA even needed something just for brochures, so they made that one up.
Okay, considering the distance of the asteroid, how do you know this is a metallic asteroid?
So how much metal is in it?
Detect this, yes.
Spectroscopy mostly. You know, you can, if there's light bouncing off of it from the sun, it will absorb. Depending on the material that's there, it absorbs different frequencies of light.
Who does this?
And so that's probably the main way.
Who does this research? Is that by here on Earth, or it's done by this outside, like the station, or they send some
well,
to that?
Yeah, so far, I mean, it's just been research. I mean, astronomers do it because that's what they like to do. You know, they typically get funded. You know, there's a certain amount of university support, a certain amount of government support, you know, to fund those kind of things. Now there's going to be a lot more commercial pressure to do it, and we'll get into that a little bit. But yeah, right now it's catch as catch can. But that has definitely been one of the goals. Anytime they have the probe sent up by NASA, for instance, it is definitely a goal to determine as best they can what is there. The real problem still ultimately is you can't tell what's underneath. You know, unless you blow it apart. I mean, you know, you don't know. You're really telling, you know, that there's certain compounds on the surface, but they may not be representative, you know, depending on how the asteroid was formed. Also, what's on the outside has been exposed to solar wind for billions of years, like the moon, and that changes the surface. It's actually quite different than what's underneath it in some cases. So that could be happening here. We don't really know. Okay, so the growing knowledge, the biggest single lesson here lately is that rubble piles are pretty common.
That changes the nature of mining. The picture on the right, which we showed before, represents the traditional view in mining. A spacecraft would grapple the asteroid. If you look closely, you can see the cables holding the craft in place. Then you would use big drills to drill the asteroid. That's not going to work on a rubble pile.
The new generation of companies are doing it a little bit differently.
There's another older model, which was that we moved the asteroids into either lunar or Earth orbit to make use of them where there's more need for them, right? And yeah. I remember Heinlein's story about lunar mining operations that were basically dropped into the ocean down the Earth's gravity well, right? And they decided to revolt and dropped one in Montana.
Yeah.
And instead, so it seems like, is that still even on the cards, or is the political opposition to that just for obvious reasons just so high that it will never happen?
Well, I think actually one of the problems, if you're really dealing with rubble piles, it's not so easy to tow them. Although one of the companies, I got to say, is actually what they're going to do is they're going to put a big bag around the asteroid. But the second thing, however, is they're only going after small asteroids. So you don't have that risk of well, one, they're going to do as much refining as they can at the asteroid instead of coming back, instead of dragging the whole thing here. The other thing is they're working with smaller asteroids. So I think all those problems kind of go away. I don't think there's going to be political opposition so much, on that, because you're not risking the Earth by accidentally going, oops, I meant to put it around the moon and instead it dropped on Moscow. That's just not going to happen.
By accident on Moscow, heck of a sabotage opportunity,
Yeah.
isn't it?
Yeah, but fundamentally the new approach is pretty much do as much refining as you can out at the asteroid itself. Only bring back the product you're trying to do, and that, of course, that cuts down on transportation costs. But again, there is that problem that there aren't many asteroids maybe that you can really tow easily, unless you can put a big bag around them. And it's pretty hard to get a big enough bag around the city killer. So I think we're probably going to be okay there. Okay, so newer startups, there's two of them. TransAstra, actually, they're pretty early. They got in about 2015. And they're going to focus on in-space delivery of products, in particular water. That's their goal, is to get the water out there. AstroForge is the other one, who was just formed last year. And it's interesting because they've already got missions going out as ride shares this year. So they've moved pretty quickly on this. But they have a completely different approach. They are going to try to bring back the platinum group metals, meaning platinum and some metals that are near it on the periodic table, and bring them back to Earth. I'll talk about that more. But anyway, radically different visions. These are totally different than we've talked about. So the real question is going to be, have they solved all the problems?
A question came up on which asteroids will be mined.
In the case of AstroForge, they specifically said, no, we're not going to tell you. They were very specific about that. In the TransAstra case, I don't know. The trick is that, first of all, you got to find these things. The ones that actually have a lot of metal in them, they probably consider that a trade secret. They just don't want people knowing. So the first one, TransAstra, they have a technology called optical mining. What they mean by that is they basically use solar reflectors to concentrate heat in a very, very tiny area, and they turn it to plasma, essentially, and then they can do the separations from that. Now, this particular picture here, this is maybe more in transit.
Some key items are the solar reflectors, which are the silvery dishes. They concentrate the sun's rays, which are redirected with secondary and tertiary mirrors, depending on whether they are mining or traveling. The bag covering the asteroid is the orange ovoid shape in this medium-sized craft called a honeybee.
So what they do is they capture the asteroid in a big bag, essentially. Then they heat it up, but they don't heat the whole thing. Again, they concentrate in a very, very tiny little area. They basically, you hit like 4,000 degrees is what they're aiming for. And this just vaporizes, turns it to plasma. So they fracture that. Now, with that heat locally, though, that does drive out all the volatiles, meaning as a gas, meaning in particular water. That's the thing you're really looking for. And most asteroids have water, so they think anyway. So that's not so much of a trade secret like the metal ones.
And then they catch the water in what they call an ice trap. Those are the smaller white spheres above the orange bag.
And that's their plan. So what's interesting is that there's no real energy cost for this. The sun provides all the energy. And ultimately, that's true with solar cells as well. But the difference here is they're going directly for thermal energy from the sun just by reflecting it. They're not even bothering with all the inefficiencies of converting it to electricity first, then doing something with it. You could say, in a way, that's probably a lot more efficient, which may explain why these reflectors do not seem that big to me. I would have expected much, much bigger. But I think it's just because you avoid all the inefficiencies of converting to electricity and then doing something further with that. The other thing, of course, is you're also avoiding maintenance or even the mass of mining equipment. You don't really have mechanical drills. All those old kind of things you saw were rugged oil-filled roustabouts were drilling into the solid rock and all that. You don't need any of that. You're just blasting it apart with solar energy. Now, there is a demo coming up, meaning a spacecraft, and They were hoping for 2023. I'm guessing it's probably more like 2024, but it's a 250 kilogram spacecraft, so 500 pounds roughly. It's actually sponsored by NASA.
It's a Phase 3 project in NIAC, which is NASA's program to support small, innovative projects developing new technologies.
They go through a cycle every year of funding a lot of these things. And this is the first one to make it to Phase 3. So they've done pretty well with this. Now, the next one, and this is a very small one. The next one would be this one that's in the picture here, and that's going to be about 5,000 kilograms, so 10,000 pound kind of size. And that's the one that's going to go out and is going to try to get the water out of asteroids. They're kind of the size of a house. They're targeting like the 15 to 50 foot kind of diameter. So I'll see if I can show you this video. This is the mini beam, which is the one that will do either this year or next year.
In this picture, the bag is the opening on the right side of the spacecraft, and you can see the solar reflectors with the silvery inside surfaces. They're sending up a sphere made of simulated asteroid material as a test. And this picture shows the approach of that simulated asteroid. This is all done in low Earth orbit. Here's an animation of the entire sequence.
Okay. So that's the asteroid as they're moving in on it. So, sorry, this is a bit advertising, you can't help that. So let's say there's more. So the mini beam is what's going to do it. That's it there. It's open mouth. So they're going to go, this is the asteroid. So they use solar energy to fire the engines to their the asteroid. I'm not sure that provides the power to turn these things. That's why they use water. They're trying to say, well, to apply that, extract the water around that, so extract the water, and then use that as fuel to go home. And that's definitely the science fiction. So that's definitely not your average marketing video. All right, so anyway, that's coming up hopefully this year, but probably next year.
What's really striking about this is that with the exception of modern automation, both the propulsion and the mining are based on 19th century Victorian steam technology and mirrors, which they had back then. In science fiction terms, this is truly the first steampunk spacecraft for mining.
The fact that they're relying so much on direct solar thermal energy for everything is really kind of interesting. Their business case is surprisingly solid. They're going to use a lot of small, inexpensive vehicles, like maybe bigger than the space speed, but the first one is not all that big.
Someone asked if the asteroid has to be spherical.
Probably not. But, I think they're just limited to a maximum radius, whatever the biggest radius is. And yeah, most of them are probably potato shaped anyway. So, but anyway, they're going to keep their costs low. They're not going out there with the giant queen bee thing that they were referring to. They'll start with the smaller ones, and that'll avoid any problem with saturating markets in any case. So the value proposition is you go for a house-sized asteroid, you can get maybe 100 tons of water out of that. And maybe you can do that in a few months plus the travel time to get there. So maybe an extra year or two coming out and back. Now you're competing against water that's being lifted off the surface of the Earth. Now, actually, just a couple of years ago, they were saying, well, that was $10,000 a pound. Well, okay, well now it's more like $5,000 a pound, and quite a bit less depending on where you're taking it. Low Earth orbit actually would be less than that. But anyway, at that price, 100 tons from Earth will cost you about $1 billion. So just doing that one house-sized asteroid, bringing back the water, you could probably charge a whole lot less than $1 billion, and still, have an easy market for it. So that's their goal. Now, Starship's probably going to screw that up by at least a factor of 10. So, we'll have to see how that works.
A comment was made that after extracting the water, there will be leftover asteroid pieces.
They don't say. Yeah, I assume they just leave a little pile of rubble kind of around. They don't really say. That's a good point, but they don't actually say. That's just not in any of their literature. I was asking myself that same question. Yeah. Well, an awful lot of asteroids just kind of are conglomerations anyway. They'll eventually come back together if there's a pile of them. We're probably going to see that actually with what happened with the asteroid that DART, the project went into. We blew a lot of stuff all over the place. It's gradually going to coalesce and come back together. Gravity does that. So. Anyway, but in the meantime, the big thing they're doing is they're saying they're trying to be cash flow positive every year. And they're doing that by getting a lot of research grants. They already are, I think. And they license intellectual property and services. So a lot of that has yet to occur, but they're still a fairly small company. But they have some good technologies, and those technologies are exactly the things they need to achieve their goals. But they're trying to sell it. So they have this thing called the Sutter Space Telescope, and what they're focusing on is tracking fast-moving faint objects. Now that's something that actually the big telescopes aren't really that good at doing. They just don't. They're not focused on that because nobody really cares about those except these people. They care. But you can take that same technology and you can apply it to looking for orbital debris. Tracking orbital debris, which is getting to be a bigger and bigger issue because there's so much junk up in space, and also military threat detection. That's a whole new market that they hadn't even thought about when they started this company. And now they're getting funding actually for both of those things, the orbital debris and the military threat detection. That's the space telescope, but then also there's the bagging. Well, they can bag an old dead satellite, or they can bag up some piece of scrap that's up there, and move it. Maybe they'll have a collection point where they collect this stuff. Who knows what they'll do with it? But they are getting funding for doing that. Because not only governments care about that, but actually all these operators of big satellite constellations, they care because it gets in their way too. So.
A comment was made about the need for a junkyard or multiple junkyards at different orbital heights.
Well, that's an extension of what you have now, right? Because you have right now for the old geosynchronous satellites, the ones that are way up at 22,000 miles, when they die, they actually move them up to a higher graveyard, and that way it's just kind of out of the way. They're still up there. But yeah, I think that's just an extension. They probably will have to do something like that because it still ultimately costs a lot of money to bring something down. To expend the fuel to slow something down costs you money. And so maybe they'll pile it up, and you look at it as it's resources. Someday when they'll have forges up there, they can just melt all that metal down and reuse it. And that probably makes more sense to take advantage of that. It's up there already. So, I guess you could think it'll be like the Pacific Vortex where they catch all the pieces of plastic. Well, maybe they'll do that on purpose up there because it's better to have it in one place than it is to have scattered all over the place. So anyway, they're getting all these grants. Space tugs, and we've talked about those in past meetings. As what companies like SpaceX are bundling, they'll take up 100 satellites at a time to a particular sun-synchronous orbit in particular is what they usually do. But that isn't always where people want to go. So space tugs can take those, the cheaply lifted satellites that come in these giant transport missions that SpaceX calls them. They can then move them around with space tugs, meaning it's literally what it sounds like. It's just a small vehicle that moves satellites around and can place them in different orbits. And they're trying to get money for that. The bagging and removing, as I said, they got funding on that. And the rocket engine, the steampunk rocket engine here. They can probably sell that because it is something that you might be able to support. You know, you're going to be roaming around the universe, at least around, you know, the asteroid belt or something. You know, water is available. So, and the other point they make that is easy to forget, and that's that they're not going for the asteroids out in the asteroid belt. This is not the expanse. This is something much closer, near Earth asteroids. They're in comparable orbits to the Earth, or they cross the Earth's orbit, you know, but they're easier to get to. They're not that far. In particular, the energy it takes to get to them, which is usually measured by delta V, is actually cheaper than going to the surface of the moon. So if you're going to do some mining, if you were thinking of mining on the moon, it actually makes sense to consider mining an asteroid instead. And the other thing is, there's probably millions of them because people haven't bothered to track them that much. They haven't named them all. They know about 30,000 of them. So there's at least that many out there. But a lot of them are hard to see because you end up looking into the sun. And so there's probably a whole lot more out there. So they're saying, we're going to find them. And that's actually why they have their Sutter Space Telescope. They're going to use that to find it. So they've thought through, I think, a lot of the basic problems here. Okay, so the second company here, AstroForge. They're doing asteroid mining of metal on a very small scale. And it's a 2022 startup. And already they're planning on launching this year. I mentioned that. They're focusing on the platinum group metals, which if you're wondering what those are, there's palladium, iridium, osmium, and whatnot. These are metals that are in limited supply on Earth. I mean, we have them, but they're widely used and are likely to get even more widely used. So there's a market for that. They just say bring it back in small quantities. Get 100 kilograms of platinum, drop it down, you know, have a heat shield to slow it down, and then have a parachute landing. You know, and that's what they're hoping for. They emphasize they're kind of a pure play in asteroid mining. They're not selling technology along the way. They're taking the exact opposite stance of the previous company. They think that's a distraction. Now, to me, that says red flag. You know, they're probably going to have trouble funding themselves long enough to actually make this all happen. But yeah, maybe they're right. Maybe because they're moving so fast, maybe they'll get it done. Their initial round of funding was only like $15 million. They've hardly spent much of any money. And one thing they do, they emphasize that they're just using standard satellite buses and things. They're not developing a whole lot of new technology. The only technology they develop is their separation process. And that's in they split it up as a three-stage process. Well, first they go to the asteroid, they move the ore into the spacecraft, and then what they do is they vaporize parts of it in a cloud of atoms. One source I found said they're using a laser. I don't actually know if that's true, but you know, could well be. They say that they're going to ionize those basically individual atoms with a positive charge, and then sort them somehow. And they don't specify how they're doing that, but it has to be electromagnetic. There's almost just no other choice. There's something you could do. We actually had a presentation here of somebody who did something very much like that. Dr. Amelia Grieg, she's a professor at University of Texas, El Paso, and she gave a speech on something that they're doing actually for lunar mining. And it was another one of these NIAC innovative things from NASA. You know, funded by that. Now, the way they generate the ions is different. She's using an electric arc in her case, and that was on the surface of the moon. But basically, you end up getting a bunch of ions, you know, individual atoms with a charge. You get them, you shoot them along. You probably pull them along with a negative charge grid somewhere. You focus it, and then just basically send them through a permanent magnet that deflects them to the side. And the heavier they are, the less they get deflected. And so you sort them out, and they all. I mean, they're showing it here. It's like kind of collecting in a bunch of vacuum, you know, thermal jugs or something. But that's the basic principle. They have not said how they're doing this in the case of AstroForge, but it almost has to be something like this, given what they've said so far. So that's my best guess, anyway. So missions, as I said, there's 2 missions this year, one in April and one in October. The first one is just going to try out the refinery technology. So this is the thing of vaporizing it. So they're going to take up a simulated asteroid again and just. Now, this is very small. This is literally a CubeSat, the 6U, you know, 4 cubes, 6 of those, that size, sort it out. And then they're going to do the next one is to go out and find a near-Earth asteroid. And this is the one they're not specifying. That's their trade secret. They're going to just do a flyby. Now, one thing I'll comment on is all these are going as ride shares on other missions, which means, of course, their schedules could easily get thrown off. You know, that happens all the time. But so their schedules are always at risk. But then if that all succeeds, then they'll go to an asteroid and actually bring a sample back, and they'll try the analysis and extraction and everything there. And then if that all goes to plan, then they'll go and actually do the real thing. So that's their plan. So 2 things with definite time frames subject to, you know, availability of the rockets that are taking them. And then, you know, 3 points 3 and 4 are somewhat Anyway, so that's what they're doing.
Well, that concludes the talk today on asteroid mining. I hope you enjoyed it. For videos on other space topics and news, visit our YouTube channel and the webpage.